Hi folks, this video is going to explain how to do the problems for this week's work on acceleration and graphs of motion. When you open this file on Teams, you'll see that page 1 has the notes from last week telling us how to describe the motion of an object using a speed-time graph. The key bit of information is up here. You'll see that there are 3 different shapes of line that can appear on a speed-time graph. If the line is horizontal and goes straight across, it means the object is travelling at a constant speed. If the line is going diagonally upwards, that means the object is increasing its speed, so we say that it has positive acceleration. And finally, if the line is going diagonally downwards like this, we say the object is decreasing speed, and that's what we would call negative acceleration. So have a read through page 1 to make sure that you're able to describe the motion from a graph. You'll see on the second page, on the left hand side, it tells us how to calculate acceleration by using a speed-time graph. You'll notice from the box in the middle, it's got the equation that we've learned for finding acceleration. A equals v minus u over t. Just to recap on what those symbols mean, we've got A is acceleration, which is measured in meters per second squared, m/s, and squared on the end. V is the final speed of the object, either at the end of the journey or the end of a stage in the journey, and speed is just meters per second. The U stands for initial speed. So the speed at the beginning of the journey, or at the beginning of a stage in the journey, also measured in meters per second. And the final quantity is just time measured in seconds. Now what you'll notice is that instead of a sentence or a paragraph that describes the motion of an object and gives us some key numbers, we've got a speed-time graph instead. So what we're learning to do is to take numbers from a speed-time graph and substitute these numbers into the acceleration equation. So your first step for these problems is to make a list down the left-hand side with all 4 symbols in the acceleration equation. All of these problems are going to ask us to find what the acceleration is, so A will always be a question mark. What we need to do next is mark on the graph where the line that shows the acceleration starts and then where that line ends. That will help us get the final speed and the initial speed. So you can see that these are marked in for us already. Where the line starts is next to 5 meters per second. So that goes next to U. Where the line ends is opposite 45 meters per second. So that goes in for V. And then the final bit of information we need to go into the equation is the time. So we need to look along the x-axis where we find time. You can see that the line starts above 0 seconds and it finishes above 8 seconds. So the period of time that the object's accelerating for is between 8 and 0. So we want the time difference between these two numbers. And in this case it's simple because it's just 8 minus 0. That tells us that the object is accelerating for all 8 seconds shown on the graph. So on our list, time becomes 8. You'll then see here that they're writing the equation for acceleration. You don't need to write the word acceleration, just write A equals V minus U over T. And then they're substituting in the numbers. So you'll see from our list, V is 45 and U is 5. So we get 45 take away 5 on the top line. And time underneath is the 8 seconds. Now if you want to, you can add in an extra bit of working to make it easier to find the final answer. 45 take away 5 can be simplified to just 40. And that makes it easier to find the final answer, which would just be 40 divided by 8. And then that gives us a final answer of 5 meters per second squared. For the moment, you don't need to worry about the direction that it's headed. You just need to write down the final answer with the units. Now you'll notice that they've written down ms minus 2, which is slightly different to what I wrote above here that was m/s squared. Both versions are correct. So you can write down the one that you prefer. So your units for A, you can either write m/s squared, or you can write ms minus 2. What you shouldn't write is m/s minus 2. Okay, you would lose the mark for unit if you wrote that, because that's not quite correct. And very quickly, we can also say the same for speed, for the units for speed. So V and U both have the units of meters per second, which you can write down as m/s, or you can write down as ms minus 1. And for speed, what you shouldn't write down is m/s minus 1. So make sure that we're using the correct units for speed and for acceleration, like I've shown you here. You'll see on the right hand side of page 2 that there's 2 little examples. So I'm going to talk you through how to do these 2. First step, again, make my list. Down the left hand side. Every problem is going to ask us to find what A is, so that's always going to be a question mark. So that just leaves me with V, U and T. Like that. Next step, on the graph, mark where the line begins and mark where the line ends. Okay, now it's always going to be a diagonal line, either upwards or downwards, to show us acceleration. Where the line begins is at 0 meters per second, so that can go in next to U, is 0 meters per second. Where the line ends is across from 10, which you can see I've already marked in. You can either draw a dotted line across or take a ruler or a straight edge and line up the end of the line with the scale for the speed. But we can see that it clearly finishes at 10 meters per second, so that value goes in for V. Now if you struggle to remember which one is the final speed and which one's the initial speed, think of your alphabet. In the alphabet, U comes before V. So U, because it comes first, it becomes our initial speed. And V, because it comes second, is our final speed. The last bit of information we need from the graph is the time. So we look at the bottom axis, the x-axis for time. We can see that the line starts, the diagonal line starts at 0 seconds and it finishes at 20 seconds. So time is 20 seconds. What I want to do next is put down the equation v minus u over t, and then I can substitute. So this time v is 10, and that gets taken away from u, which is 0, and that gets divided by 20. Now I would normally take a new line, but I'm going to just put it to the right hand side because I've no space, just for this one. What I can do next is I can simplify that top line. 10 take away 0 is just 10. So that makes it easier for me to find the final answer. If I do 10 divided by 20, it gives me a final answer of 0.5 meters per second squared. It should be a positive answer because you can see the line on the graph goes diagonally upwards, which means positive acceleration, and that's what I've got in my final answer. Next example, same again, make the list down the left hand side. Acceleration is what we're trying to find in all of these questions, so that's question mark. Then I want to mark where the line starts and where the diagonal line ends on the graph. Now I can see the start of the line is 90 meters per second. So that goes in beside u. The line ends across from 30 meters per second. And again, I would take a ruler or straight edge and draw a dotted line on the graph across from that end point so I can check that for sure. So my final speed for this one is 30 meters per second. The last thing I need is time, so I'll look on the x-axis again for time. The line starts above 0 seconds and it finishes above 80 seconds. So my time is 80 minus 0, which is just 80 seconds. Now I can put down the equation, A equals v minus u over t, and then I can substitute. So for this one, v is 30, that gets taken away from u, which is 90, and all that gets divided by 80 seconds. Now from the top line we can see that it's a small number take away a big number, but that's okay because for this one you can clearly see the line is sloping downwards, which means the speed is decreasing. So it should be a small number take away a big number on the top line. Because if I simplify that, 30 take away 90 gives me negative 60. And it's a negative answer that I'm going to want because that line's sloping down the way. So simplify it, minus 60 divided by 80. And that gives me a final answer of negative 0.75 meters per second squared. So I should have a negative answer when the line is diagonally downwards. After page 2, there's another 2 examples on page 3 which I'm going to go through just now, and then you'll be able to do the rest of the problems on the other pages. So same process again. For this one, put down the list on the left. Acceleration is what I'm trying to find. Then I mark where the diagonal line starts and where it finishes. I can see that it starts at 0, so my initial speed u is 0 meters per second. It finishes on the top right across from 20, so my final speed is 20 meters per second. And then my final bit of information I need is the time, so I'll look at the x-axis. The line starts at 0 seconds, finishes above 5, so that's 5 take away 0, which is 5 seconds. Can put the equation down and then substitute. So V is 20, that gets taken away from U, which is 0, and that gets divided by 5. I want to simplify the top line. 20 take away 0 is just 20, and that gets divided by 5, makes it easier for me to get my final answer. 20 divided by 5 would give me 4 meters per second squared. And it's a positive answer because the line is going diagonally upwards. Second example, same again. Put my list down the left. Acceleration I don't know. I want to mark in where the diagonal line starts, where the diagonal line finishes. So I can see the line begins across from 20 this time. Okay, it's not starting at 0. Not all of them will start at 0. Some will be like this one where it's slightly above. So my initial speed is U, and that's 20, because that's where the line begins. And the line ends on the top right hand side across from 80. So my final speed V is 80 meters per second. Last bit I need is time. So look on your x-axis. The line starts above 0 seconds and it finishes above 15 seconds. So I want that time difference. So 15 take away 0 just gives me 15. Can put the equation down. Then substitute. So I've got 80 for V, that gets taken away from U, which is 20, and that gets divided by 15 seconds. I can simplify the top line. 80 minus 20 is 60. That gets divided by 15, which also gives me a final answer of 4 meters per second squared. And again, it should be positive because the line's going diagonally upwards. You can now do the problems on pages 4 and 5 and 6, 7 and 8. The only other thing that I'm going to point out just now is I'll use this as an example. So when I've been getting the value for time from the graph, you'll notice that I've always wrote a subtraction sum. And this is important because not all graphs, like you can see here, not all diagonal lines from the graph start at the 0. This one, we would mark in that it begins here and it ends here. So we do the same process again to find the final and initial speed. So the line starts across from 2. So that would give us initial speed is 2 meters per second. You can see the line ends across from 6. So final speed would be 6 meters per second. The time along the x-axis doesn't start from 0 and finishes at 25. So we can't write down the time as 25. So if we wrote time as 25, that's not the right answer because it's not accelerating for that whole 25 seconds. If we look at the graph, we can see it starts accelerating at 10 seconds and then it stops at 25. So for the time, it's not going to be 25 because it's not accelerating for the whole period shown in the graph. What we would do is we would say the line stops at 25 but it started at 10. So that means for this example the time would be 15 seconds. So that's something to watch out for with some of the problems later on. Make sure you've got the time interval only for the diagonal line, showing the positive or negative acceleration. So you can now do all the problems on pages 4, 5, 6, 7 and 8. As usual, if you've got any questions, please post them on Teams.